Okay, so bacterial spot is a disease that impacts tomatoes. It causes lesions to form on all above ground parts of the plant. Little dark brown to black raised spots begin to cover the leaves and stems and flowers and fruit of the plant. Eventually, the infection causes the plant to develop a sort of scorched look. It can even cause the abortion of flowers, drastically reducing the yield of the plant. I went to Florida to visit the lab where they're working to solve this problem, but it's worth noting that this isn't just a Florida problem. We've got the same problem up in Ontario in Canada as well, and it can be an issue wherever tomatoes are grown. Bacterial spot is a black spot on tomato growing. So this is Dr. Sam Hutton. He's an assistant professor of horticultural sciences, and I spent some time talking with him about this disease. Bacterial spot is actually spread by bacteria known as Xanthomonas. This presents a big problem. The genetic variability of these bacteria makes it difficult for plant breeders to develop a stable resistant plant variety. Pathologists also can't come up with a chemical solution for the same reason. So finding a workaround to make tomatoes resistant to bacterial spot is the goal.
The original tomatoes that were domesticated were highly disease sensitive. And so every time we have a new disease or we want resistance to a new disease, we're usually going back to wild tomatoes and looking for resistance there and trying to use classical genetic approaches, classical breeding approaches to bring those genes over into cultivated tomato.
Now, scientists did manage to find a gene within the tomato that could be made to express resistance, but it didn't perform well in trials. There was no workable gene for resistance, even in wild tomatoes. So scientists turned to a relative of tomatoes to find the gene, sweet peppers. Sweet peppers have a gene that helps them be resistant to bacterial spot. They're related to tomatoes anyways, so it made a lot of sense to borrow this gene and get it to help tomatoes too. So how would a scientist like Sam go about doing that?
Agrobacterium, right? This bacteria inserts its own genes into plants and hijacks the plant systems to get what it wants. That's what happens in nature.
In fact, sweet potatoes were naturally modified by agrobacteria. They've got bacterial DNA naturally. So scientists just figured out which genes from the bacteria were getting inserted into things like sweet potatoes, and now they can just replace them with the genes they want inserted.
Whether it's a Roundup Ready gene or whether it's this pepper gene, we put that pepper gene into the agrobacterium. It inserts it for us, and now we can get tomatoes containing that gene. That might not have happened naturally.
But nature gives scientists the mechanisms they need to make changes to genes. It's surprisingly straightforward, yet that doesn't stop the public from really hating transgenic plants like this tomato. This thing scientists created is frankenfood, so logically, it's a no-go for most of us. But for 7 years, field trials have been conducted, and they show conclusively that not only do these tomatoes fully resist bacterial spot with no pesticides at all, but the yields also get a bump too. Check it out. This is a plot of tomatoes with no modification.
So there's no transgene in here from pepper.
And that's why we're seeing the effects here.
Exactly right. So this is where the disease is getting started in these trials. It's a little bit early yet, but pretty soon the whole plot will be infected. You can see it's already spreading to the neighboring plant right here, just from natural infection. We actually inoculated these plants today and yesterday as well, and you'll see plot-wide effects pretty soon.
These infected tomatoes are doomed, but the transgenic tomatoes are a different story.
So these plants do contain that gene from pepper, which is controlling bacterial spot.
And like wonderful control here, wonderful.
Yeah, so again, it is early in the season. We'll see more disease in some of these plots later on, but right now, no disease at all. And the impact of this is really incredible. When we have conditions favorable for disease, we can double our yields quite easily just by controlling bacterial spot.
Win, win, win. Yet, for most of us, we just can't get over the idea that transgenic means frankenfood means science run amok.
But in this case, we're talking about a gene from a pepper plant. People are consuming this already, maybe in peppers right now. This is a gene that's been used for decades by pepper breeders for control of bacterial spot in pepper. You can't cross tomatoes with pepper naturally. So the only way to get this gene into tomato was to use this transgenic approach.
It's been a while since I've caught up with Sam, but I ran into an interview with him in a recent article for Growing Georgia by Lynn Hayes. Currently, given the climate around GMOs, no growers are willing to bite the bullet and take that first step. This stigma against transgenics that the public holds is one reason why there aren't a lot of tomato operations who want to scale this thing up. Another reason is that one estimate puts the cost of safety testing and deregulating this tomato at $136 million over yet another 7 years. Bottom line, until somebody who grows tomatoes for market is willing and able to give this tomato a shot, farmers are stuck using the same control methods they've been using for the last 60 years, copper-based pesticides. And although they work, they have some major disadvantages when compared to this GE tomato. For one, copper-based pesticides are toxic and have to be applied with caution, and you have to apply it as much as 44 times a year. And in Florida's case, that amounts to $100 million spent annually. Also, these pesticides have been shown to accumulate in the soil, causing negative impacts on soil health, and copper-based pesticides can kill off beneficial bacteria, roots, plants, snails, fungi, you name it. Maybe you're starting to see why people like Sam think transgenics is a reasonable tool to consider using in this case. After all, from a scientist's perspective, the term GMO is a lot less loaded than from a consumer perspective.
Genetic modification, in my mind, can involve classical breeding, such as what we do here. It can involve transgenic technology, which is what we've looked at out in the field as well. It can involve genome editing technologies. So
maybe this idea we have that all things GMO are frankenfood and are therefore bad. Maybe we've all got some catching up to do. Okay, that's too much pun for one day.